In this really useful tutorial, we are going to look at building a granular synthesizer. I am sure there are lots of other tutorials out there that cover the same thing, but a series on fun synthesis methods wouldn't be complete without one, so here we are. Before we get going, let's save our empty patch into a folder. This is important because we want to make sure our audio files are also in this folder. You can see that I have two WAV files in mind. Nancy and a quick loop of Apex's xstyle from selected ambient works. Obviously, the starting point here is to be able to play a sound file. Let's look at how to load, store and play back audio files. The storage object is the array. We create an object called ArrayDefine and then give it a custom name, in this case GrainArray. You can double-click on the object to look at the waveform, but obviously there's nothing in there yet. We load a file using the SoundFiler object. We use a read message with the resize flag, our file name with the .wav extension and finally the name of our array. If you link this to the SoundFiler and click it, this should load the file into the array. You can then double-click to view that in the array. Now then, how do we play that back? We use the tab read for object, giving it the name of our array. To actually play that back, we can use a lined object that generates an audio signal from one number to another. The 0 means start at sample 0. The second number is the endpoint, also in samples. The third number is the time to take to go from one number to the other. Slightly confusingly, this number is in milliseconds. We can add some other objects to simplify the creation of these messages. We will create a list of 3 numbers and use the $signs to arrange them in the right order. We add a value to our start point to get our end point. We want to specify a playback duration, the duration of our grain, in milliseconds. Since the sample rate is 44,100, we can multiply by 44.1 to convert the duration in milliseconds to a duration in samples, so that we play the audio file at the correct rate. We also use the sample rate object to automatically adjust the sample rate just in case it isn't 44,100. We will want lots of these grain players to build our granular synth, so it is useful to include it in a saved abstraction. We will add a receive object so that we can easily change the grain duration. Now we add an inlet and an audio outlet. Finally, copy and paste it all into a new file, leaving the array and sound file objects on the top level patch. Save the patch as something like grain.pd. This now makes our grain triggering nice and neat. It is important to have some kind of volume envelope for each grain that turns the volume up and down smoothly. We trigger two things, a 1 to turn up the volume, and a 0 to turn it down again. The off message will not happen immediately but after a delay, so we add a del object. These numbers go into a pack so that we tell the lined object how much smoothing to apply, in this case, 50 milliseconds. The delay time will need to respond to the grain duration, so that we start to turn the volume down 50 milliseconds before the end of the grain playback. Great. It's really coming together. What we could do now is create lots of grain sub-patches and set up a painfully complex system to trigger them. But that is a massive faff. A much simpler way is with the cloned object. See our rich synthesis tutorial number 3 for more on the cloned object. We can now easily say that we'd like 16 of those bad boys, thank you very much. And just trigger each one in turn with the next message. We can easily trigger random grains like this, with the different grains overlapping to give a cloud of sounds that all come from one audio file. What if we want to play through the file, though, and do things like time stretching and that kind of thing? Well, let's have a look. We can use a phase or object to keep track of where we are in our sample, triggering grains at regular intervals. The phasor usually goes from 0 to 1, so we will need to scale it by the length of the sample so that it goes from 0 to however long our sample is. We use the snapshot object to get a new value and trigger a grain to play back at that point. That works, but how do we know how fast to set a phasor so that it plays back at normal rate? Well, we can work it out from the duration of the sample. We just divide the sample rate by the duration of the sample to get the frequency at which to play back at.
In the time that grows between you, you may try.
We can also set up and multiply objects so that we can then scale this rate.
But you will not erase her image with all your one-night valentines. In the time that grows.
A new control has more useful units, where 1 is normal rate, 0.5 is half speed, 2 is double speed, and so on and so on. You can hear some strange effects in the sound. This partly comes from triggering grains at very regular intervals. It can be helpful to add a little randomization to the grain rate like so.
In the time that grows between you may try.
You can hear some strange effects in the sound. This partly comes from triggering grains at very regular intervals. It can be helpful to add a little randomization to the grain rate like so.
With all your one-night valentines. In the time.
That's about it, really. You could make some additions to the patch like offsets to the playback position or scaling the phase or output to create loops at different points in the file. You could also add an option to change the smoothing time in the grain patch, or alternative ways of triggering grains. Have fun with it.